Okay, so while I'm restarting my server, so I'll start with this. So again, the same. We will start the second version, second part. So now we will talk about the ROS basic, but we don't have much time because like now it's already like 9+. I need about 1 hour for this. So I will cut everything very short. So you need to learn a lot of things by yourself actually, because 5 weeks is actually too short for me to cover everything. So the approach for you to actually learn from this class is you need to do a lot of self-learning. Okay, so what is ROS? Okay, I hope the server is back now. Okay, still need some time. Okay, so ROS is a system that helps us to manage a lot of software. So before ROS, we already start to develop a lot of robotics application. We already start to develop robots for many years. But the problem is we always come with a lot of different piece of software, different languages, some using C, some using Java, some using Python, and so on. And we have a lot of problem to make them communicate. For example, like the TCP/IP way, the socket way to make them work, and so on. So a lot of very tedious stuff that we need to do everything from scratch manually. So that is before ROS. But once we have ROS, it standardized a lot of things. It standardized the communication, it standardized the language, standardized the compiler and everything. So with ROS, in brief, I can't explain in everything, but in brief, it helped us to speed up and standardize robot development process. Okay, so over here you can see like the plumbing, the process management, the inter-process communication. So these are the things that I just said. The device driver. So for example, you have your motors and your sensors running on different driver and they run on different OS. For example, your driver only can run on Windows. When you want to mount it on your Mac machine, then you got problem and so on. So yeah, so ROS helped us to solve for this problem. Then it got a lot of tools. For simulation, we have the gazebo. The visualization, we have the RVs, and then GUI and data logging. Data logging is like, for example, the ROS back is very important for us to do analysis, especially if you do research work. Then you need to have grabs all the data and do your plot, your graph, and do analysis and so on. So this data logging tools is already available in ROS, so it have all these things. Then the third one, very important for ROS, is it provides us a lot of capability. And this capability is actually because ROS is open source and its community contribute. So a lot of people, for example, some expert in navigation, they really contribute the navigation capability to the ROS community. So everyone able to do autonomous navigation now with just running the ROS navigation package, which most of us actually don't know what actually happening down there, but it doesn't matter because now we are talking more on high level development. We don't build everything from scratch. So in this class, we will learn according to your level. So, but most important thing is we want to solve our problem. So we try to use whatever capability that we can gather and make our robot works first. Make it able to recognize the face, then only we study how the face recognition works. So that is actually a very different from traditional learning, but my team actually benefit a lot of this way. We can build a lot of robots, a lot of function without actually knowing how to write all this algorithm from scratch. So ROS gives us the capability to do so. And lastly, of course, the ecosystem. You can find a lot of resources explaining when you face problem, and also you can find, and also like workshop like today, we also like over here telling you how to use ROS. Okay, this is still not working. Okay, I guess, okay, I guess I will leave with this. Is it that bad? Okay, so I will skip this part because, well, this is basically you can read by yourself. But most important thing over here is it is free and open source. Okay, so for ROS, you can actually use it for even for commercial development. Yes, as long as you know how to manage with the license and everything. Yeah, everything is legal and fine. So that's why we use ROS. Okay, right. So ROS, just a very brief introduction, is it run with a master. So For ROS 1, we are talking about ROS 1 because now we already have ROS 2, and the concept is very different from ROS 1. It's quite different. So for ROS 1, we have ROS call, which is the main part. So you can run the ROS call, and then to start all the management. So this ROS call will manage all your node down there. So node is something that it will run a very single function. For example, the sensor will have a node to make the sensor read the data. Then the motor will have a node for the motor to turn. Then you coordinate these two nodes. When the sensor reads something, then the motor moves. So yeah, so it is like this. So you can have node 1, node 2, and then your master. And this is basically similar to the example I just said. You have a sensor, you have a actuator, then yeah, they communicate with each other, then you make it work. Right. Then in order to run the ROS node, okay, I will skip this part because I'm going to show you the demo later on. You just do ROS run package name. So all the node in ROS is arranged in package form. And then under each package, you have several nodes that relate to that function. For example, the sensors or the motor package. Then, for example, this node is like, for example, read sensor data. The motor is, for example, the turn to left and so on. Right. Okay, then you can list down, and then you can see the info. Info means the meta information of the particular node. Okay, I'll run this very fast, so I hope you do the reading by yourself from the ROS tutorial. Then the master will actually coordinate all the nodes, but when you want the node to function, they have to talk to each other. They have to have interaction. So in order for them to interact, we use a concept called ROS topic. So ROS topic connect ROS node 1 and node 2 to make them talk to each other. And in order for one topic to exist, someone have to publish the data or create the topic and publish the data. So that is the publisher. And then when you have the topic exist with certain data flowing, then another node can subscribe to this topic, and yeah, with that, the data will flow from the first node to the second node. Okay, so this is how the communication works. And you can use, of course, the echo and the info. The echo basically print out the data inside the topic, and the info, you can see the meta info of the particular topic. For example, who is the publisher of the topic and who is the subscriber of the topic. So these are the concept. Then for the messages are the data flowing inside the topic. It can be as simple as integer, array, and so on, as it can be as complicated as, for example, like this post stem example, and yeah, you can have very complicated. For example, like you have your video stream as your message. You can have like 3 float number as your message and so on. So these are like, no matter how complex or how simple, you use the same mechanism to make them publish and subscribe. So that's the beauty, because ROS standardized all this. And that's why I say just now, the communication between the software becomes simplified because of this concept. Okay, so now this is the demo time. So let me do the demo. Okay, my server is still not working. Okay, it's back. All right, okay, I think like I need some help to upgrade the server. Okay, so this one, I need to put this thing down. Oh yeah, I forgot to bring up my terminal. Okay, wait, let me bring up my terminal. Okay, so I have the workspace. So now let me, okay, if you want to see what I'm doing, you just click on this. But please don't do anything. Okay, just look at it. Okay, so I will show you how this thing works. It works like this. Where am I now? Over here. Yeah. Okay. Right. So can I have this thing? ROS basic. Okay. Right. Good. Okay. So now I'm over here. Okay. Maybe a bit small, but you can read from your terminal. Okay. Okay. So over here, I do Ros call. Right. So I have my Ros running. So if you have this, then that means your Ros is running. Okay. Then I run one example, which is Ros run Ros CPP. Ros CPP tutorial. Okay. Then Talker. So this Talker basically is a node that publish certain message. So you can see it published the hello world and then you do the counter 0, 1, 2, 3. So this is a node, okay, that publish a certain message. Then you can check, of course, you can use the Ros Note List. Okay, you can use this one, Ros Note List. You can see now I have the Talker. Ros out is basically the output from Ros. Okay, so it's always there once you have the Ros call, but Talker is the node that we just executed, which is now is executing. Okay, it's running. Okay, so we have this. Then you can find the info, which is a Ros Note info, then Talker. Ooh, sorry. Okay. Okay. Then you can see over here it say publication, chatter, and Ros out. So this chatter is the topic that published by the Talker. Okay, this one. Right. So you can verify by Ros topic info and then chatter. Oops. Okay. Ros. Oh, okay. I typed wrongly. Ros topic chatter. Okay. So you can see the publisher is Talker. So this is the relationship. So you have the chatter, Talker as the node, and it publish the topic called chatter. Okay, and then the message, the data inside the topic is hello world 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, so this is the publisher. Then we have we analyze. Okay, enough of this. Okay, now we want to run another node. So open another one, but put it here. Okay, this one put here, never mind. Okay, so I run another node, Ros run Ros CPP. Okay, it's too small for me to see. Tutorial listener. Okay, so this listener, you can see it say I heard then hello something. So which means it actually get the message from hello world here. So the Talker publish the message and the listener subscribe to this topic and get the message. Okay, so that's why it heard something and so on running. So now if we analyze, now if we run list, then we have the Talker and the listener list, right? Then if we check the info for the chatter, now you can see if the publisher is Talker and the subscriber is listener. So it complete the example that I said just now. Okay, so this very, very simple example is the things that I want to show you. So now just to show that I can actually push a message into this topic without using a node. So for example, now this is running, right? And this is running also, right? So if I Control C, I stop this, the Talker no longer publish, the chatter also stop. So which means it don't receive any new message after 2172, no more, right? But if we do manually to push something, just to show you that we can actually, the topic still there, Ros topic publish, and then chatter standard message data, then I put, for example, RoboCup. Okay, so I already pushed this data out, and if you go to listener, you can see it received I heard RoboCup. So it receives. So which means the topic still there, the subscriber still active, is still listening. It's just the publisher no longer publish the data. Okay, so this demonstrates the whole thing. So this is the example that I want you to know. Okay, to show you. So just now it's the publish subscribe. Okay, I'm going to skip through the rest of this. For example, like launch file. If, for example, I want to launch both listener and talker at once, I don't need to ROS run one by one. I can use a launch file. I put these two nodes together and launch one time, and both will be running. So launch file basically is to launch a set of nodes for certain function. Okay. Okay, there's file structure and so on. This one you can read by yourself. Argument, yes, read by yourself. This one also, yeah. Then we have the Gazebo simulator. Okay, so Gazebo simulator. So if you do Gazebo, then we have the Gazebo. Okay, I'm not sure it works here. Is it working? Is it running? No, it's not running. Okay, so Gazebo is not working on web-based, so it have to use the RDP, which is I will show you the RDP later. RDP. It don't work. Wait, let me turn off this first. Gazebo is not working. Okay, let me see Gazebo. Is it there? Yeah, it's there. Okay, yeah. So just now maybe I'm running something, so it'll work. Where is it? It's still not running. Okay, so Gazebo, because it required this 3D rendering stuff and so on, so it don't work on web-based. So I can only run it with, which is I will show you later, okay? Because today we are not talking about Gazebo. So this Gazebo, we can use the RDP, the second option for the virtual desktop to show you the demo, which we'll use later. So basically it is a simulator to simulate our robots. So just now you see the Jupyter robot have the Jupyter robot model to show you the arm, the move it, solver, and so on. Right. So yeah, a lot of things you can do without a robot. Just this. So as a future reading, you can read a lot of related, which is I recommend you to understand all this concept. What is ROS package structure, ROS C++ library if you are using C++, or you just learn the Python one. Right, but C++ is always need to have some knowledge about C++ because like when you refer to other people's code, most of the old, I mean like, especially those that require intensive computing, it will be written in C++ actually. So yeah, it is always good to know the C++ library for ROS. And then the RVs, the visualization, we'll use a lot after this. TF, if you want to build your own robot model, yes, you need to know this. But this TF, you need to know for vision, if you need to know the distance. For navigation also, yeah, I think all the robots application, you need to know some understanding on this TF. RQT, user interface, your DF, STF, these are all the simulation model, the model of the robot model. ROS time and ROS back, yeah. Okay, then for communication, so just now I show you the publish subscribe. So that is the most fundamental communication way in ROS, but it got other, for example, the parameter server. So the parameter server is like you have certain parameters that you can specify before you start application, but when you start, it will read the parameter from the server, and then you can actually modify, or apparently like, yeah, Gazebo is not working on the web base. Right. So the parameter server will feed the data and it can modify in real time. So that's why it is very useful if you want to have certain parameters that you want to adjust during running. Okay. Then very similar to publish subscribe, you have the ROS service. This ROS service is very similar like publish subscribe, as but the only difference is it is not always available, which means you need to request the service before you get the data. right? So you need to request. So the publish subscribe is you don't need to request. Okay, you just subscribe and then you can take. But the service is like every time you want the data, you need to request and then you get the data, right? So these are the different. And then the action lib is actually a very complicated thing. For example, like the navigation use the action lib that have a lot of protocol and communication. So this one maybe later on you only need to like learn it. You won't use it for the early state, but this point you first need to learn the publish subscribe. Okay, so it is actually the assignment today for this. Okay, right. So for you to start building, you need to first build your workspace, right? So this is how you work. You build your workspace. You can read also, like go to the reference. You read what is a workspace. Workspace is where you work in ROS. So you build a ROS workspace and then you cat-kin make, which is you build the workspace. Then you create a package. Okay, so you create a package. This is how you create. You go to the workspace, under the source, you create a package. The package contains a name, so you need to call this. This is the command cat-kin create package. You create the package name. You put any name you like, and then dependence 1, 2, 3. Okay, so this one without writing also is still fine. Okay, without writing is still fine, but always we will write, for example, standard message. You always use standard message. And then ROS PY, you will definitely use ROS PY if you are writing in Python. Okay, ROS C++ is optional if you are using C++ library. Okay, so this dependence is to tell people that when you want to run this package, these are the dependency, right? But so when you don't specify, it's still fine, but sometimes it might have compile error because like people actually don't know what dependence or what library that you use in order to run your package. Okay, so like this, then you can image. Then with that, you can start your exercise over here. Okay, right, I don't have much time to run this thing, to do the demo here, but basically you need to follow the instruction at this and this website to build your publish subscriber in order to have what you just see in the talker and listener. So basically you rebuild the talker and listener. You go through how you write. I mean, you go through the example so that you know how it is developed. Okay. Usually I will demonstrate this together with my student, but because today due to time constraint, I have to stop here. So the assignment is write a pair of ROS publisher and subscriber node that for every second, okay, the publisher node publish username and counter to a topic. So just now it published hello world and a counter. So now instead of counter, you put your username or whatever name you like, right? And in every second, just now I skip one very important, which is the hertz, the frequency. You go through just now the example, you will see there's a way that you can set the frequency of the publisher. Okay, so this one is for you to try to challenge you for the assignment. Then you write a subscriber to subscribe the topic and display the topic message to a terminal, right? Okay, then you can upload this to GitHub to see if everything is working fine, right? So I have done for this, but I think this ROS maybe needs some demonstration, or I can explain this code, or I can explain the publisher and subscriber code because I feel that it's important after the class. Okay, so because now we need to stop at 9:30, so I don't have much time left. So I will try to close the session, but if for any of you who can still stay a little bit, like 10 minutes, actually I need more, but I think 10 minutes I'll try to finish all. Yeah, we can continue to listen. Okay, so just not to disturb anyone that would like to leave by 9:30. Yes, we can pause over here and we can open for question. Then after that, we can come back to see the demonstration for the publisher and subscriber. But basically what you need to do is just open the tooling and write the publisher subscriber Python code by yourself and run it. And you should get the same effect like just now I showed you. Okay, right. So my translator, can you please like yeah, conclude what I just said and also open for question. Yes, still there? Excuse me. Yes. Are you still on the line? Or I am not. Hello.
Yes.
Yes.
Hi.
Yeah. Can you actually see the last part? Because like I think my share screen is not working just now. Hello. Can I
We
talk to
saw
someone?
it.
You saw it? Okay, wait. I thought like so you see all the terminal, right? So everything is okay, right? Okay, so I open for question. Do you have any question?
Could you talk about GitHub?
You mean like how to use the GitHub, is that? Okay, so for GitHub, just now I show you a list, right? Okay, a list of GitHub. GitHub. Okay, so for GitHub, over here. So I actually have a list of GitHub example. Okay, yeah, this is a bit small. Okay, so for GitHub, what you need to do is you go to GitHub and create an account, right? Then you can start to learn how to use GitHub. A very easy way if you can set up the GitHub your Git repository using VS Code. Okay, you can just like use the plugin and then you key in your username and password, and then in VS Code you just need to like upload or commit, then you can commit. Okay, but the manual way is this. So over here you install, which is already there, you join, then you need to set your global setting, which is your username and your email address. Then you can init a test. So once you init a test, you write a README file, and then you can add any file or folder that you like. Then you commit. You commit means you write like at this point, everything that I've done, I will record down. Okay, so you commit. So it is like a point that you record. So you commit. Then you write a short description to explain about this point. For example, like I have updated README, for example. Okay, then in the GitHub, you can create a new one, or you can use the GUI on the website you can create. Then over here, you can, push the file. So git push origin master, you push the file up. So this is how you push up. So whatever that you write here will be pushed up. Then you refresh your GitHub repository. You can see your tests over there. So you just follow these few steps. Basically, you can push. So the assignment today is like I want you to learn how to push the package that you create for the publisher and subscriber. Okay, so you need to publish this and then to the GitHub, and you can see your source code at GitHub in your account, under your account. So that is basically the exercise. Okay, I explained in very brief. You need to learn a little bit more by yourself, but you can actually find a lot of tutorial video that explain every single step of what I just said. But I already summarized down steps that you need in order to push your code to GitHub. And then to git clone, yeah, basically you clone it down like this. Yeah, so in brief, to explain GitHub in 3 minutes, yeah, this is my explanation. Any more question?
It's about talker, chatter, and listener. If I don't miss the command RoboCup tutorial is the code that provide to create talker, caster, and listener also.
Sorry, I don't really understand what you say, but you can refer to these 2 last link. Okay, the last 2 link that I put it over here. So this link, simple publisher and subscriber. So you just need to follow this. Okay, you just need to follow this exactly. And you will create 2 files. Okay, so first you create your package. Okay, so yeah, first you create your package. So this is your create your package. Then you create a script, which is your to a folder to put in your Python code. Okay, so then over here you can actually download this example, or you can use your VS Code or your gedit, whatever editor that you like, to write this file. Okay, so the file is over here. This is the file that you need to create, and this is the Python code for Talker. So after you create this, then you get the explanation here. Okay, so this is something I want to do actually. I normally do this in class, but yeah, I don't have the luxury of time in this classroom. So you have to read it by yourself, but I don't think it's hard for you to understand this. If you have any question, yes, you can ask me next class. Right, just follow this. Then you create another file called the subscribe, it's called the listener.py, which is the subscriber. So over here, just a few lines, you can see you remove the green color part, which is the command. It is just a few lines. Okay, so you can create a subscriber. So this is how you create a subscriber. Then you just build, catkin make, you build, and then you run your talker.py and listener.py, and basically you will get the same result that I just showed you in the Ros C++ tutorial.
Okay, thank you.
Okay, so yeah, this is what you need to do. Then after you finish all this thing, learn how to use the git function to update this to your GitHub repository. Of course, if you learn how to use the VS Code way, that will be easy. Okay, currently, normally I will use the VS Code. VS Code, you know what is VS Code, right? It's my, oh yeah, okay. Yeah, the VS Code is this one. This is the Visual Studio Code, right? So this is the editor that I recommend you to use, and that inside there they got a plugin that after you install plugin, it will ask you about your GitHub password and username. You complete it, then every time you just need to click the button to push, then you will push to your repository. You just need to do the setup. Yeah, you can do the GUI way or you can do the command way. It's up to you.
Is this compatible with PyCharm?
Yes, if you want to use PyCharm, yes, but for ROS, you need to write many other things. So yeah, I think VS Code will be how to say, will be more universal for your application. But of course, yes, if you focus on PyCharm, yes, you can use PyCharm. But normally I will use VS Code for my editor. Previously, I used just gedit.
Okay, thank you.
Okay,
I will use VS Code.
Yeah, I will recommend you to use VS Code. Okay, any more question? Basically, I already explained for the publisher and subscriber. So I will expect you, so you have a lot of homework. Okay, first you need to set up your environment. Then after that, you need to sign up for GitHub, and also if you're using Robot for All, then you can sign up for the virtual desktop. Then you create your package, okay? And then you learn how to create a package. Go back to the tutorial. I say all these things very fast, okay? So you need to read step by step by your own. and then create the package. Then you create your node, which is the talker node, talker.py, and your listener node, these two nodes. Then you run, like just now what I show you, and you should get the same result. And that is the process how you create a package and you create a node. So next week onward, we will have the speech, and I will, with this fundamental knowledge, then you will start to learn different package, different functionality, and so on. Okay, so basically that is for today. I will still be here for any question asked. If you don't have any question, yes, anyone who would like to leave, yes, you may, yeah, also I already done my things. But before that, I would like to ask my translator from Thai, maybe you can help me to summarize the whole thing just in a very brief way so that they know what they need to expect or what they need to do, especially for the homework part to prepare for the next week.
โอเคครับก็สิ่งที่จะต้องทำมาเนาะในการเรียนครั้งหน้าเนี่ยก็มีตั้งแต่การลงในส่วนของUbuntu 18.04 นะครับลง Ros Melodic แล้วก็ถ้าเป็นไปได้ก็ลง Ros ตัว Turtlebot 2 มาด้วยนะครับแต่ว่าใน choice ที่เขาให้มาในส่วนของ Ubuntu Setup เนี่ยอย่างที่เขาแจ้งนะครับว่าchoice แรกเนี่ยค่อนข้างอันตรายเนาะในส่วนของ Dual Boot ซึ่งบางครั้งเนี่ยอาจจะทำให้ข้อมูลที่เรามีเนี่ยสูญหายไปได้นะครับก็ให้ระวังนิดนึงหรือว่าถ้ามีความหรือว่าลองไปดูในอินเทอร์เน็ตนะครับว่าเขาทำกันประมาณไหนเนาะแต่ว่าอย่างที่บอกครับ backup Windows เก็บไว้ก่อนก็ดีนะครับถ้าจะเลือก choice ที่เป็น dual boot เนาะส่วนถ้าเป็น choice เป็น virtualbox หรือว่า choice ที่3เนี่ยก็ไม่ค่อยน่าจะต้องกังวลอะไรนะครับก็อย่างที่เขาว่านะ choice ที่เป็น virtualbox อาจจะต้องใช้ในส่วนของresource ในการทำงานเยอะขึ้นนะครับโอเคแล้วก็ในส่วนของsession ที่2เนาะที่เขาจะให้เราไปทำมานะครับก็ไปเขียนนะครับในส่วนของ Ros Publisher กับ Ros Subscriber มาโดยที่ก็ไปลองอ่านดูนะครับว่าเขาให้ publish อะไรแล้วก็ให้subscribe อะไรมาให้ดูนะครับแล้วก็ทดลองอัปโหลดขึ้นไปบน GitHub เนาะซึ่งในการเขียนทั้ง Publisher และ Subscriber นะครับก็เขาก็มี reference link มาให้อยู่แล้วนะครับแล้วก็หากท่านใดมีเวลาว่างอยู่ต่อเนาะก็น่าจะเดี๋ยวเขาน่าจะอธิบายให้ฟังนะครับว่าโค้ดตัว Publisher กับ Subscriber เนี่ยเป็นประมาณไหนนะครับส่วนในส่วนของวีคหน้าก็จะเป็นในส่วนของRobot Speech นะครับก็ขอให้ทุกท่านเตรียมในส่วนของ Ubuntu กับ Ros มาให้เรียบร้อยนะครับน่าจะเพียงพอต่อการใช้ในอาทิตย์หน้าครับโอเค Jeffrey is
Yeah, thanks. So everyone, I hope like you enjoy this class because I speak in very fast pace. It's not easy to follow, I understand. I will try to put up the video later on, you can review, but more importantly, please go through the slide and do the reading by yourself. I already recommend you a lot of things to read. You need to, do your motivation, self-motivation to read and to learn. Okay, so all I need you to do is set up your system, understand how to build the Ros package for publisher and subscriber, and try to understand the concept of publisher and subscriber. Once you know this, you can follow the class in future in a very easy manner. Okay, because later on, everything will be just publish, subscribe, and you just call the function, and then you can build your robots with that. Okay, right. So with that, thanks a lot. I will open the Q&A after this, but I would like to close this session. So thanks for coming, and I really very happy for this big turnout. We got like 80 plus today. So I will give some time for the question and answer, and we can feel free to interact with me. But for you who will need to leave by 9:30, so thanks a lot, and I hope to see you next week. Thank you very much. Okay, right. So the session already ends here. And if you have anything you want to ask, yes, feel free to ask me now. I'm
okay.
Sure.
Jeffrey, Ganja here.
Yep.
And let me, because I already create like a Thai language about like a basic Ros. So is it possible to send you the link? Then you can just give to a person who would like to learn Ros in Thai language.
No, you mean it is a video or what is it?
Yeah, just videos.
Okay, yeah. If you don't mind, I can just upload to our YouTube channel and I can share to everyone.
Okay, that is good.
Yeah.
Okay. let me translate to Thai a little bit because maybe somebody frustrated about this โอเคครับเดี๋ยวผมจะเอาลิงก์นะครับที่ไปสอนเป็นพวก basic loss นะครับเป็นภาษาไทยนะครับเดี๋ยวจะส่งไปให้ทางเจฟฟี่นะครับเพื่อจะเอาไปขึ้นบนเว็บนะครับสำหรับบางคนเนี่ยผมส่งอีเมล direct ตรงไปให้แล้วนะครับสามารถดูได้นะครับเป็นแบบฟรีนะครับโอเค thank you very much Jeffrey
All right, thanks a lot. Thanks for your contribution. Yeah, I think the video will be very helpful for all the users to know ROS because the concept itself is not easy to understand. And if I speak in English, maybe it's even harder for you to understand. So yeah, thanks Kanjanapan for the very nice effort. Right, so other than that, do we have any other question? Yes, we have friends from many places. So I would like to hear like if you have any comment or because this is the first class, I would like to know is my style of this is okay for you, and if you have any feedback, yes, feel free to tell me now. And also the class already ended, so you may leave now, right? If you have nothing to ask or say. Yeah, but anyone who would like to interact, I would like to listen to you as well, right? Yes, and you can tell us or you can feedback, comment to us in Thai language if you like. Our Thai community is still here, Thai community member. Anything you want to ask? Friend from Malaysia, anything that you would like to ask from your point of view, I would like to hear as well. As a first class, I would like to know like if this class will be useful for you and will you come back again next week? Yes, please tell me so that I know how to improve my delivery so that you can benefit more in this class.
ขออนุญาตถามเป็นภาษาไทยได้ไหมครับ
Yes, feel free to speak in Thai.
คือว่าที่ทำ virtual machine บนเว็บไซต์นะครับคือว่าข้อมูลจะถูกทำลายทุกครั้งที่ปิดมันใช่ไหมครับแล้วทีนี้คือการที่มี GitHub ก็เพื่อที่จะเซฟงานหรือเปล่าครับ
ใช่ครับก็ส่วนหนึ่งแต่ว่าเท่าที่ฟังมาคือมันไม่ได้ถูกลบหายไปไหนนะครับแต่ว่าแค่มันจะแชร์กับท่านอื่นๆที่ใช้งานร่วมกันนะครับบางครั้งอาจจะเกิดขึ้นได้ครับอาจจะมีคนไปลบหรืออะไรอย่างเงี้ยครับก็ใช้ GitHub ในการเซฟไฟล์ก็จะง่ายกว่าครับผมแล้วก็เซฟด้วย
แสดงว่าถ้าคนอื่นไม่มาลบของเราก็จะยังอยู่แบบนั้นเหรอ
ครับเดี๋ยวผมลองถามเดี๋ยวลองสอบถามเขาเพิ่มเติมให้นะครับexcuse me Jeffrey
Yeah, no problem. Yes.
He asked for the virtual for the virtual desktop on the robot for all workspace is they remove all the file every time that have another user sign in or not.
Okay, so for the VNC version, which is the web-based version, yes, you cannot save your file there because like other user might access your file. But if you apply the beta tester, you will have a dedicated account, which is the file will be remain with you throughout the periods you have that account.
โอเคก็เขาบอกประมาณว่าถ้าเป็นตัวที่เป็นเว็บเบสที่เป็นอันบนที่มันกดได้เลยครับอันนั้นก็อาจจะเขาว่าจะไม่ค่อยเวิร์กเท่าไหร่เพราะว่าคนอื่นก็เข้ามาใช้ได้เนาะส่วนอันล่างที่เป็น RDP ที่เป็นbeta tester ครับอันนั้นเขาบอกว่าจะอยู่ไปเรื่อยๆจนกว่าจะจบคอร์สอันนี้ครับ
Yes, so please apply if you are faculty member or team leader, you can apply a beta tester account here and you can use this account throughout your period for this whole testing period. Yeah, your file will be there. But not for this, okay? So this one is share. It's just for everyone to practice during the class, but this one you can do it later on and you will have a dedicated account for your use. Because we want to see like if this will be useful in future for everyone to learn using, because the actual one is actually this RDP, which is we will use the Microsoft Remote Desktop protocol or platform client in order to access. So it's not web-based and it gives you more stability and also functionality. For example, the 3D render will be better So just now the GitHub is not, the Gazebo is not working because the web base is really like very limited functionality where we can do in the web-based system. But but for the RDP, yes, it can run Gazebo and Speech, as I personally have tested. Yes. Any more question? Yeah. For the one that you raise your hand, yes, you can ask.
Yes, my question is, what's the difference between open platform and standard platform? Because tomorrow we're going to have a standard platform.
Correct. Okay, so open platform is self-made, customized robot. So you can build any robot, any open source robot, Turtlebot, Jupyter robots, any robot is fine. Okay, as long as you follow the regulation, is open platform. Open means open to anyone, any design. Standard platform is everyone will be using Pepper Robot. So that's the difference. So
Okay,
tomorrow,
thank you.
if you come to the class, you will learn how to develop with Pepper Robot. Yep. Question? Any other question? I still have 60 plus in the list. Yes, you may leave, or if you have question, yes, you may ask me. Right, or you have any comment or anything, feel free to ask me. Or if you want to ask in Thai, yes. Any friends from other than Malaysia and Thailand, I would like to hear from you as well. So yeah, feel free to say hi to me. Okay, so this is already like, out of the class time. So yeah, you can feel free to say anything. Yeah, I would like to hear from you, okay? Any comment or any suggestion on this class so that, yeah, we can improve over the time. Or if you have any question, you don't know where's the materials, where's this and where's that, what to do, how is next week and so on, yes, feel free to ask as well. Okay, if you have no question, yes, I would like to politely ask you to leave the room so that we can eventually close the session. Thank you very much. So I'll see you next week, okay? Okay, I guess everyone is leaving. Yeah, if for Thai committee member, if you have any other things that to add, yes, feel free to tell me. I just received the Thai Ros course. Yes, I will share it later on. Okay, no more, right? Anyone in the list? Okay.
Mr. Jeffrey,
Yes.
is it okay to use other Linux distribution besides Ubuntu, like Debian?
It depends on if it is supported by ROS. I got to understand that yes, it is possible. If you go to the ROS website and you see the requirement, ROS is able to run on other variant of Linux distribution, but I don't know how stable it is, and I never tried before, so it's totally experimental for you.
Oh, okay.
Okay.
Thank you.
But yeah, Ubuntu is so far the most stable one for ROS 1. So yeah, it depends on what you want to try.
Okay,
Yes.
thank you, Mr. Jeffrey.
Yeah, welcome. Thanks a lot.
Thank you for the class today.
Yeah, thanks. Okay, any more? No more? Right, so I will stop here. I think like we also okay. Right, so thanks a lot, and I will see you next week. Okay, so if you are interested on standard platform, yes, feel free to come tomorrow. Okay, to know more. Right, thanks a lot. See you. Thank you.
Can you say?
Thank you.
Bye bye.